I waited for 3 more minutes. Okay, so guys, the next topic is HDFS, that is Hadoop Distributed File System, the storage layer of Hadoop. Let's quickly see what is the agenda for this particular section. We are going to see HDFS introduction, then we'll see HDFS nodes. We know there are two type of nodes. Then the Daemons responsible for HDFS. Then we'll see the data storage mechanism of HDFS. Then we'll see its basic architecture, that is architecture 1. Then we'll discuss its feature in great details. Few important flow, that is file read operation and file write operation. After that we are going to see rack awareness and then advanced architecture or architecture 2. Let's quickly start the introduction of HDFS. So guys, what is HDFS? What is HDFS? HDFS is a file system designed for storing very large files running on cluster of commodity hardware. Commodity hardware, non-expensive, low-end hardware. So guys, HDFS is designed for storage of large files of terabytes to petabytes range. It is designed on principle of storage of less number of large files. Now guys, another important point, HDFS is designed for storage of less number of large files. Why so? So guys, if you recall by the way, the main thing is in terms of processings, also in terms of storage also, because HDFS is not developed for small files. It provides fault tolerant storage layer for Hadoop and its other component. Guys, do you know all its components? If you recall in the architecture, in the ecosystem, I have shown you other components also, like Hive, like Pig, like Flume and all. All these components are ultimately going to store the data inside HDFS only. For all the Hadoop ecosystem, storage layer is common, that is HDFS. Just for the processing we have another mechanisms. It stores data reliably even in case of hardware failures. Suppose your hard disk crashes, network link goes down, your system is burnt out. In such extreme scenarios also, your system will be highly available. Your data will be reliably stored. And now, it is distributed file system that provides high throughput access to application data, what we have already discussed, that instead of low latency, it is more focusing on the high throughput, and this feature it is getting due to distributed storage. Now let's understand in terms of HDFS nodes. So guys, there are two types of HDFS nodes that works in the master and slave fashion. Guys, please note down. NameNode is a daemon that runs on the master. Master is also called as NameNode. Master is also called as NameNode, but an actual NameNode is just a daemon that is running on the master. And DataNode daemon that runs on all the slaves. DataNode daemon that run on all the slaves. So we have a master node, we have n number of data nodes. Now guys, master node is a single point of failure up to Hadoop 1. Up to Hadoop 1 we have just one master. Please note down this, up to Hadoop 1.x we have just one master. So being a master, if there is just one master, it would be single point of failure. What do I mean by single point of failure? Guys, if NameNode goes down, the cluster is inaccessible. The same question I have given to you, all of you guys. Why? if NameNode goes down, the cluster will become inaccessible. I am having 101 node cluster, out of which one master and 100 slaves. The question was, if NameNode goes down, what will happen? Now please answer this. One point I have mentioned that if NameNode goes down, cluster will be inaccessible. Now question to all of you, why? Appreciate your answer. Sandil answered correctly. Good. Expecting few more answers. Mohit, Mani, Pratik. Second correct answer. So Mohit and Sandal answered correctly. Guys, why if master goes down, then complete cluster become inaccessible? The reason is we won't be having access of the metadata. On master node, we are having all the metadata. It means where are all the blocks corresponding to the files are stored. Apart from that, we will be having the information about the slaves, about all the blocks, about the network configuration, about the slaves, all complete information. So if your master is down, your actual data that is stored on the slaves will be of no use. But this particular issue has been resolved in the latest version of Hadoop that we'll see later. So guys, if your master goes down, all the currently running MapReduce job will also be failed. Now, so guys, with this I'm giving you 2 points parallelly, that is corresponding to Hadoop 1 as well as Hadoop 2. So we'll be having the complete sessions of Hadoop 1 also as well as Hadoop 2 also. Although Hadoop 2 related things we'll see later only. What is exactly the new in Hadoop 2, that we are going to specifically discuss later. Apart from that, whatever things are common we are going to discuss during our sessions. Now, slave nodes are expected to fail at some point. Hadoop is having this in its design principle. So guys, that's why Hadoop has developed that if your slaves are going down, few of the slaves are down, then also it won't be any issue. Now, for these slaves, I already told you guys, it is a commodity hardware, but can I take master as the commodity hardware? Can I choose a hardware of master as just the commodity? All of you guys, please think about it. Giving you 30 seconds, then answer. So guys, since we are having usually in the small cluster, we are having just one master. That's why it's not recommended to have master as the commodity hardware, because master is a single machine. It can be single point of failure. Apart from that, master machine, there are few hardware considerations also that we need to keep in our mind, that in terms of memory and in terms of CPU disk also. So in just currently being at the abstract level, just I would say you can note down, master machine shouldn't be the commodity hardware. This machine should be a reliable machine that shouldn't go down at any point of time. So guys, for these slaves, they can go down at any point of time. This is an assumption that while developing Hadoop. So guys, NameNode will automatically re-replicate the blocks that were on the failed node to the other slaves. That we'll see later. So guys, that's about the HDFS nodes. Now let's talk about the HDFS master. HDFS cluster consists of a master server that manages the file system namespace and regulates the access to cluster, regulates the access to file, regulate the access of the cluster by the clients. Guys, a master is a manager that doesn't really do the work. Its main work is to manage, coordinate, monitor, but this is the very important machine. It manages all the slaves. It manages all the slave nodes and assign work to the slaves. Apart from that, it executes file system namespace operations like opening, closing, or remaining files and directories. So guys, if there is any operation related to the namespace, that is going to be start from the master only, like opening, closing of the files, or the renaming or other type of things that is done from the master. Master should be deployed on reliable hardware. It should be highly available as it is a single point of failure. So guys, please note down this as an assignment also, although I have explained you in great details. What is a single point of failure in Hadoop 1.x and how to resolve the same? What is single point of failure, SPOF, single point of failure in Hadoop 1.x and how to resolve the same? Apart from that, guys, okay, let me assign someone who will note down and who will remind me of the assignments. Anyone taking this responsibility that he will note down all the assignments and will remind me? Sandil, will you do the same? Thank you so much for this, because these assignments I haven't noted down at any place. These are on the fly assignments while discussing these concepts with you. Let's talk about HDFS slaves. HDFS cluster consists of number of slaves which actually stores the data. Guys, master machine doesn't store the data. On the other hand, slaves actually stores the data blocks. Actual worker nodes. Slaves are the actual worker nodes which does the actual task of read, write, process, and so on. Slaves are responsible for serving read and write requests from the file system's client. Ultimately, the request of the reading, writing, processing goes to the slaves. Although there is a master ahead of them which will regulate, which will manage, which will maintain all such requests, but ultimately these requests are going to be slaves because actual data is on the slaves. They also perform block creation, deletion, and replication upon instruction from the master. HDFS slaves, Hadoop slaves, or data nodes, they can be deployed on the commodity hardware. Okay, so guys, if we discuss a little more about the HDFS daemons, the very first daemon is the NameNode. Guys, we already discussed about the HDFS daemons, right? Two daemons, NameNode and data nodes. NameNode, this daemon runs on the master. Now guys, please note down this, what exactly is stored on the master or NameNode. NameNode stores the metadata like file name, file path, number of blocks, block IDs, block locations, number of replicas, slave related configurations, etc. Your NameNode stores all these metadata. Now guys, please note down another important point. NameNode keeps this metadata into the memory. NameNode keeps the metadata into the memory. All the metadata is available in the memory. Why so? For the fast retrieval. For the fast retrieval, NameNode keeps all the metadata into the memory that is available for the fast retrieval, because if the data is in the disk, then there will be disk seek that will sufficiently degrade the performance, because NameNode's metadata is usually in what should I say, frequently utilized by the clients, by the cluster, to get the access of the blocks, to process the blocks, everything, all the requests are going ahead via the NameNode only, that is via the metadata only. All of you guys, till now, is this clear? Can I say now that my NameNode's hardware, can I make one point that I should have little high memory, little high RAM on the NameNode? Can I say this? Because it is keeping my all the data in the memory. Although, guys, understand this carefully, although a persistent copy of the same is stored in the disk also. It's not like if your NameNode is going down, you'll lose all your metadata. The persistent copy is available in your disk, but for a fast retrieval, it is keeping the data in the memory. That's why I would say your NameNode should have higher memory. Now, again, it's time for assignment. There is, by the way, there is a thumb rule. If you do a little bit Googling, you'll find out. So the assignment is corresponding to a block, how much metadata is, what is the size of the metadata that is getting created on the master. Corresponding to one block, how much metadata is getting created on the master. What is the size of metadata that is created on the master? Now guys, there is some intention, there is some reasons why I am giving these many assignments. The very first reason is that you should identify the resources. You should identify where exactly these things, actual resources are there. And apart from that, if you start doing these R&D, if you go to 3 to 4 websites to identify these solutions, to identify my questions answer, this thing will be permanent to you. This thing will be pretty much permanent with you, and while doing the research of one topic, you will find at least 3 new topics, at least 3 new terminologies, at least 3 new different technical terms or different things. So you'll again and again going through that. And guys, to all of you, it's my humble request to finish all the assignments before the next session. Pratik is asking to repeat the question. Pratik, the question is corresponding to a block, corresponding to a data block, how much metadata is created, or what is the size of metadata that is created on the master. The second daemon is the DataNode. DataNode daemon, it runs on all the slaves. DataNode daemon runs on all the slaves. DataNode stores the actual data. DataNodes store the actual data. Now let's move ahead. Now guys, important point, this is how exactly data is getting stored in the HDFS. Understand this carefully. When a file is stored in HDFS, guys, now I think it's third time that again I'm showing you this. The file is broken down into small chunks, that is 64 MB size. Whenever a file is stored in HDFS, it is broken down into small chunks or small blocks or small pieces, That is, the default size is 64 MB. These blocks are stored on the multiple nodes in the cluster in distributed manner. So guys, usually Hadoop tries to distribute the data as much as possible, and my data is more distributed. More the data is distributed, more the performance, better the performance I am going to get. So suppose out of say I'm having a 100 node cluster, and if the data is distributed between 50 nodes only, so just 50 nodes will come into the picture while the map reduce, while the processing, rest 50 will be idle. So guys, it is the philosophy of Hadoop, it is the design principle of Hadoop, that is to develop or to distribute the data as much as possible. Since data is stored distributedly, it provides a mechanism for MapReduce to process the data in parallel, over the cluster. So guys, surely MapReduce is the heart of Hadoop, but to provide the distributed capabilities to MapReduce, we must have a file system that itself is distributed, that is HDFS. Now guys, I think it's first time that I'm giving you another concept. HDFS stores multiple copies of data on different nodes. That is, by default 3 copies of blocks are created. By default 3 copies of blocks are created. Replication of data provides fault tolerance, reliability and high availability. So guys, if you recall, I have given you these 3 features of HDFS in the Hadoop session, but how they are getting these 3 characteristics, these 3 features, it is due to replication. So now if I'm having, just a minute, let me check. Yeah. So guys, data storage in HDFS, if you recall, my data blocks are stored in distributed manner. Apart from that, if you see, by default 3 copies of data is created. Look at this, block 1 is here as well as here as well as here. Block 2 is available here as well as here as well as here. In this manner, all the blocks are replicated thrice. Means overall 3 copies are there. Overall the replication factor is 3 by default. All of you guys, it's very important funda, it's very important things, although it's little tough to digest. Why? Because now you'll ask me, if I'm copying 100 terabytes of data, it will consume 300 terabytes of space. That's totally correct. That's totally correct. That's totally correct that it is going to occupy 300 terabytes of space. But guys, do you know hard disk spaces are very cheap nowadays? So everybody is pretty much okay, pretty much happy in investing this much in the hard disk, because on the basis of just from the multiple copies of the data, if I am getting these facilities, like reliability, like fault tolerance, like high availability, that's why Hadoop's fundamental principle is that create multiple copies of data. Now guys, if you create multiple copies of data, now I think nobody asked me about this question, that if any machine goes down. So guys, look at this, if this machine goes down, no worries, my data, my block 1 is available here as well, and master knows block 1 is here as well as here as well as here. Master knows block 1 is available at 3 different locations. So Pratik is asking what are the advantages of 3 copies. Pratik, I am explaining the same. If you concentrate here, there are chances that at any point of time any machine goes down. If this machine is down, I can access my data from here, from this slave. And even suppose this machine is also down, I can access my block 1 from this machine. I can access my block 4 from this machine. All of you guys, the main advantage of multiple copies is high availability, fault tolerance, reliable storage. Pratik, have I answered your question? Okay, a good question. Sandil is asking, will there be a possibility that 4 data nodes are down which has similar block? Correct, Sandil, there is a possibility. So suppose even not 4, even say if I make it 3, suppose if 3 data nodes are down, look at this, block 1 is available here, here as well as here. In such cases, I'm going to lose my data. I need to wait until one machine is up. Until one machine is up, I need to wait. Now for the same guys, this will be a deciding factor of my replication. The replication factor is 3 by default, but I can increase or decrease the same. So if I identify, if I based on my previous experience or based on my assumption that at any point of time at max 3 machine can go down, or from the hardware team I am having this much SLA that if at any point of time 3 machine is down, they will not make the 4 machine going down. Before a 4th machine is going down, they will make at least 1 up. So if at any point of time 3 machine can go down, I am having this assumption I can make replication factor to 4. Sandil? Okay. So guys, usually on a smaller cluster, like if I'm having a 10 node cluster, usually we can go ahead with the 2's replication factor also, that in a 10 nodes at max hardly one machine can go down, although it depends on your hardware, it depends on your hardware capabilities, it depends on few other factors also, like if they are in the stable environment or not, all such things. But in the production, usually machines do not go down, usually. But Hadoop is having provision, if they are going down, then also it is pretty much fine, but up to a certain limit. Surely out of 100 nodes, if 50 nodes are down, Hadoop also can't do anything, right? So guys, if 100 machines on a 100 machine cluster, we can surely increase their application factor to say up to around 5. But again, it depends on a number of factors. Okay, I think guys, it would be a very good, although I have given you 2 points, 2 major points, it can be a good research question, good research assignment. Ideally, what should be the replication factor on a cluster of 500 nodes? All of you guys, ideally, what should be the replication factor? Ideally, what should be the replication factor on a cluster of 500 nodes? Guys, tomorrow before starting the session, we are going to discuss all the assignments. So be ready for that. So guys, is this replication is clear? If I can get a smiley if the replication is 100% clear, the reason of the replication and how exactly it is we are getting benefited with the replication. 1, 2. Money? Okay, good. Now guys, this is the very basic architecture of Hadoop. Understand this carefully. One by one, let's see each and every component. NameNode. NameNode is our master. NameNode is the master that is managing file system, namespace, metadata operations and all. So NameNode is having all the metadata with this. For the backup of NameNode, we are having secondary NameNode. Please note down this. If you haven't noted in the architecture of Hadoop, please note down now. We are having a secondary NameNode or secondary master which is for the backup of NameNode. Although it is not a very good solution, but please note down this. Now, when this is an HDFS client that needs to interact with the NameNode firstly before writing or reading any data. So guys, there are few terms, that is heartbeats. What is a heartbeat? Anybody know? What is a heartbeat? Not really? Okay. So guys, data nodes send, all the data nodes sends yeah, I got a correct answer. The system response to tell the everything. Okay, not system Sandal. It's the data node that sends a very small message to NameNode and saying that I am alive. Simply, it keeps saying it. I am alive. All of you guys, just look at the meaning. Just heartbeat. It is pretty much simple from its name only. That data node, when sending to the NameNode, it will say. Correct, Sandil. So usually this message usually is sent by the data node. That data node sent to the NameNode, then only NameNode will come to know, okay, all my slaves are up and running. Now, each and every data node is having his own separate disk where the data corresponding to HDFS will be stored. Now, if talking about the third point, that's replication. Look at this. Let's talk about this green. So this is green here, here, and here. Look at this. So 3 copy of these block are available here. Take any block like orange or black. This first copy here, second copy here, third copy here. By the way, guys, all copies are identical. There is nothing like first copy or second copy or third copy. There is no priorities between the copies of the data of the file that this is the original copy or this is the duplicate copy. No. All the copy of the blocks are having the same priority or exactly the same. So I am having this as a priority, first copy. The same copy is available here and the another copy is available here. So that's the replication that I was trying to say. And at any point of time, if machine goes down, then our master will issue the command to rebalance the cluster or to balance the cluster. It means if I talk about this green block, if this machine goes down, suppose green block's replication is now and it's under replicated. In the correct terminology, I would say it's under replicated. So from this machine or from this machine, one block will go suppose to this machine. So again it will be up. So this would be the just merely to a command that can be issued. Our NameNode will automatically replicate it. So system admin can also issue the command to rebalance the cluster. Guys, a very basic architecture that I was trying to explain you here, just to give you a glimpse of HDFS, just glimpse of flow of HDFS or exactly how the Daemons or blocks looks like. Okay, Sandil is asking a question. So at given point the NameNode will always send address of the first block in the data. No, Sandil, why? It's not really like that. It's really not really like that. Sandil is asking at any given point NameNode will always send the address of first block in the DataNode 1. No. For a specific file, suppose block 1 is, this is the suppose block 1 that is here. For a specific file, suppose this is the block 1 that is not on the slave 1. By the way, position or placement of block is usually random, but there are few factors. Just in next few slides only, Sandil, we are going to discuss the same. On what basis your block is placed to a specific slave. So your question, no, Sandil, I understood your question. Apart from your question, yeah, that is, yeah, please explain this once again if I miss any point of your question. So to other guys also. If anybody is having any questions. So Sandil, you can speak. It's, if you are, it's a little hard for you to type. If it's long question, you can speak. You can unmute yourself. I have put it down my headphones.
Yeah, Anisha. So my question is more about, let's say we have multiple applications. Let's say considering level of application.
Please speak a little louder.
Is it audible now?
Yeah, much better.
Okay. So considering 3 level of replication, so we will have in 3 different nodes, right? So my question is, every time somebody is accessing the block, it will always go to one data node. If that data node is not available, will it actually go to another replication? Is it random every time you access? You can go to any of the data node where the block is.
Okay, understood. So guys, the question Sandil is asking, suppose I am having these data nodes, suppose, okay, this is the block number, suppose 1, this is the block number 1, and this is the block number 1, and this is the data node 1, this is the data node 2, this is the data node 3, this is the data node 4, this is data node 5. The question is, every time if there is a read request for the block 1, every time this request will go here. So the answer is, it depends. Suppose at any point of time this slave itself is busy in serving other clients' request. This slave is busy in processing the data. This slave is busy in reading or writing the data. This slave is overoccupied. So this request will go. By the way, reading request is usually pretty much random. It's random. At any point of time, suppose it is this slave is serving, suppose this slave is serving, suppose this slave is serving. But there are few factors, like the first factor is depending on the if the slave is busy, if the data node is busy, so surely NameNode will ask for the another data node to respond. Second point, the distance of this client and this slave, the client who want to access this block and this particular slave. Suppose, let me give a very simple, my data node itself can act as a client. My data node can itself act as a client. If on this data node itself, if I want to read the data, so instead of pulling the data from a third data node, this data node will give the response. Just giving you the example of the distance. So if they are in the same rack, although I haven't discussed the rack, so I shouldn't take this term. I'll explain the rack and all later. So these are the few factors, Sandil, on which this reading request exactly depends. And similar is the reasons for the placements also, that in the next slides only I'm going to discuss. Sandil, is this clear? Okay, that's good. Let me clear the drawing. Erase already. Okay. So after HDFS basic architecture, let's talk about the features of HDFS. Now guys, during these features we are going to discuss about the distributed storage, how distributedly your data is stored, what is the placement policies, on what factors it depends, blocks, how exactly the data is split up into blocks, file is split up into blocks, your replication factors, how, on what factors it depends, and how the replication is actually happens. High availability, data reliability, and fault tolerance. These three features, all three are related or dependent on the replication, but what are the difference between them? And scalability. After that we'll discuss high throughput access to application data. These are the features of HDFS that let's see one by one. So guys, distributed storage. Data is distributedly stored. Data is distributedly stored across the cluster of nodes. Now, as I told you earlier as well, Hadoop tries to distribute the data as much as possible. Your data is firstly split up into small pieces and stored across multiple nodes. Now guys, due to this distributed storage only, it provides a way to MapReduce to process a subset of large data parallelly on multiple nodes. Since my data is stored distributedly, since it is split up into small pieces, due to which only MapReduce can process the data distributedly or parallelly. So guys, distributed storage also provides the fault tolerance capability. Since the data is split and distributed, due to which only we are getting the fault tolerance capabilities. Okay, let's go ahead. Okay, during the blocks we'll discuss about the block placement also. Now guys, understand blocks carefully. It is one of the most important topic of HDFS. Your files are split up into number of blocks. Your files are split up into number of blocks. Do you know the block size of OS file system is merely 1 KB, or if we talk about the latest file systems like Windows 8 also, it is 4 KB. The block size of the file system is merely in few KBs, 1 KB or 4 KB. On the other hand, HDFS block size is 64 MB. It's huge. Why so? Why HDFS block size is that much huge? And even I'm saying it can be increased according to the requirements. It can be increased according to the requirements. Correct. So since we are talking the data and that's huge, apart from that, dealing with the small size will be little difficult to manage and copying will take more time, and the reason is that there is a huge disk seek. So guys, you know that while reading any data from the disk, hard disk need to seek to that particular sector before reading the data. So if my block size is large, it is going to save my disk seek time, and that is really a significant factor if I talk about the overall performance of my framework in terms of storage as well as processing. So guys, another advantage is in terms of processing also, that is when we are going to discuss MapReduce. In the first part of MapReduce is the map. So at a time, one map task will process one block. So if my block size is small, it will process, suppose if my block size is 1 KB, it will process just 1 KB at a time. But if my block size is higher, that is 64 MB, it can process 64 MB of data. Okay, so guys, apart from that, let me ask one question to all of you. Suppose I am having a file. Whose size is 65 MB. The size of the file is 65 MB. How many blocks will be there? Correct. 2 blocks will be there. If a file, yeah, Mohit and I think Sandal, it's correct. I think you two guys answered. What about Mani and Pratik? 2 blocks, right? What? So let me create 2 blocks. Suppose these are the 2 blocks, the first block and second blocks. So what is the block size? Default block size 64 MB. Guys, keep pinging me answers whenever I'm asking questions. Be ready. The default block size is 64 MB. So my first block will be completely filled. It will be completely filled off since I'm having 64 MB data. Yeah. So first block will store 64 MB data. What about second block? Second block is merely having 1 MB of data. Now, my question to all of you is, what will happen to this 63 MB space? What will happen to this 63 MB space? Think about it. Giving you 20 seconds. Think about it, then answer. So Sandil is saying it would be left as it is. No, Sandil, how we can left 63 MB spaces? It would be quite a waste of storage, because understand, we will be having millions of blocks. We'll be having petabytes of data. We'll be having petabytes of data, and if it is wasted like this, that won't be a good solution. Money is saying used for another file. Money, since a block is allocated for just one file, how one block can have the data of two files? We can't mix that. So the answer is, please note down, if the data size is less than the block size, if the data size is less than the block size, then block size will be equals to the data size. What do I mean by that? I hope you note it down. This case will not arrive. Rather than that, what will happen? One block of 64 MB has been already created. Second block will be created of merely 1 MB. All of you guys, if the data size is less than block size, then block size will be equals to the data size. It means my block size is random in the nature. If it's not getting full, it is not going to occupy the complete space. It will occupy the space whatever is necessary. Is this clear? Okay, let me again explain the same if it's not clear. What about other guys? Sandhil, Pratik and group, and Mohit. So guys, suppose I am having a file whose size is 130 MB. Now all of you answer me, how many blocks will be created and what will be the size of the blocks? How many blocks will be created and what will be the block size? I got just one correct answer. What about money? Pratik and group? I got second correct answer. Sandil also answered correctly. Correct. Just one more answer I am waiting. So guys, overall 3 blocks will be there. 2 blocks of 64 MB. 3 blocks will be there. 2 blocks of 64 MB and 1 block of 2 MB. Okay. 64, 2 blocks and 1 block of 2 MB. So that will be 130 MB and I'll be having 3 blocks. Let's move ahead. So today we are going to let's understand the block placement policy. So guys, again means don't consider that block 1 is having first copy, second copy, and third copy is not there. Block 2 is having first copy, second copy, and third copy. It's for the illustration only. The default, this your configurations are default. So just for the simplicity, few copies has been shown here. Now we are having the name node that stores the metadata. NameNode's metadata, that is file system, file name, namespace, number of replicas, block IDs, etc. Look at the first block is available here as well as here, second block here, here, fifth block here as well as here, as well as here. On what basis these blocks are placed on these machines? Guys, if you see the block placement policies, these are pretty much random. Blocks are placed on the machines that are pretty much random, but it actually depends on few factors. The very first factor is the load on the specific machine. Suppose this machine is pretty much loaded in terms of storage as well as processing. If this machine is pretty much loaded already, your name node will try to send less number of blocks to this machine. Apart from that, the distance is also measured. Say if this machine is little far, sure Sandal, let me explain that again. So what I was saying, the block in the block placement policy, if this machine is already loaded, say for example this machine is 80%, more than 80% full, other machines are quite less having less occupied. Apart from that, here lots of work is also going on, lots of tasks are going on, that user has submitted work. So the block that is coming to this machine will be less. NameNode will send less number of blocks on this machine. This is the first reason. Second is the distance. Suppose if client is pretty much near to this machine, then its chances for this machine will be little higher to get more blocks. So guys, by the way, to illustrate this, we'll see during our workshops also, like we'll consider one of the data nodes itself as a client. Suppose from this data node itself, I'll copy the data inside HDFS. So when we'll see lot many blocks will be stored on the same machine. Lot many blocks will be stored on the same machine since the distance is quite less. So guys, these are very minor factors. Apart from that, your blocks are placed pretty much randomly. They are placed as well as processed pretty much randomly. Okay. All of you guys, regarding the blocks, is everything clear till now? Just because after this we are going to increase the depth of the knowledge, as well as we are going to go deep dive into the concepts of like replication, like other concepts. So till now, if everything clear 100%, first just I got few smileys. What about other guys? Okay, thank you Sandal. I got a big smiley from Sandal. Money, Pratik and group, Mohit and other guys. Okay, so if any, by the way guys, I recommend you, this recording will be uploaded today only in the LMS. I recommend all of you guys to go through the recordings before the next session, so that we'll continue after this. So guys, I think that we should stop for the day. Let's call it a day. But what we are going to see in the next session, let me show you that. So guys, in the next session we are going to cover replication. In the replication we are going to discuss a number of concepts like why replication, where exactly we can set the replication, or what are the different places where the replication will go. We can configure, we can edit the configuration of the replication things also. We are going to discuss about the high availability also in great details. After that we'll discuss about data reliability. Then we'll discuss about fault tolerance, scalability, high throughput access to application data. Then we'll see file access and other operations, how we can access the files and other operations. Very important concept, file read operation, that is very important. Then we are going to cover file write operation, again very important in terms of interview, in terms of certification. These two concepts are very important. Then we'll see this again another way just to illustrate file write operation. Then we'll see rec awareness, very important funda, all the small funda of HDFS. Then we'll see advanced HDFS architecture, that is having complete end-to-end picture of HDFS, what is happening, where we are going to see okay how client will read the data, or how client will write the data, or what is exactly the rec, how it is getting replicated, what is different block operations and all. So guys, that's it for the day. Hope you enjoyed the session. Next session tomorrow Sunday, same time, sharp at 8 PM we are going to start it. Alright guys, thanks so much for attending. Good night. Oh, Sandil is saying again one more awesome session. Thank you, Sandil. Mohit is saying I have attended a training at another place, but this is the best. Thank you, Mohit. Thanks for your kind words. This kind words encourages me a lot.